So when you have an angle, it always connects or intersects the unit circle. I love the unit circle at a unique point. Okay, now that point xy, that's the only point that's going to match with that angle. And then we get into all the ideas about trigonometry, like there's a triangle, and the sides of the triangle are x and y. There's a triangle and it has a hypotenuse. We can call it r. And now that same diagram is in the margin. So I just kind of want you to become a student where you can look at some stuff in the book and realize, what they're referring to. But that angle I drew will intersect at a unique point. And again, that point has an x and y, and then we get our trigonometry values. Okay, now some of those things we're actually going to focus on and spend more time with tomorrow. In other words, tomorrow we'll kind of talk about like some more triangle stuff. What we're going to actually talk about today is the graphing stuff. And if you look at the bottom of page 41, you'll see our lovely trig graphs. Take a look. I know you've seen them before. We've actually graphed at least one of them this year already, but they're the same graphs. Now they are in radians. Okay, what does that mean? It just means that the x-axis is in radians. And so look at some of the radians. It appears that all these graphs reach from 0 to 2 pi. So they go from like 0 to 360. Do you realize that the light brown on sine and cosine, the light brown is 1 period? Remember that language? 1 period is what it takes to see all the ups and downs of the graph, to see all the y values, all the cycle. Look at what the period is for sine and cosine. It's 2 pi. Notice that it's measured in radians. Now that is actually written underneath those 3 graphs. Do you see that? We also have like a domain and range that's written underneath those graphs. Okay, now the range for sine and cosine is between positive and negative 1, as the y values, as the values will never go beyond 1 to negative 1. I found a simple animation about how the unit circle actually creates the sine wave. Now, watch what's going to happen here. We're going to go around the unit circle. Every time we go around the unit circle, we'll be touching y values. Okay, some of the y values will be positive, some will be negative. Okay, but as you go around the unit circle, you touch y values. Those y values are going to get graphed, and they create the sine wave. Just watch. Okay, now kind of just stop right there. We have a y value. Okay, it's like right there. It's almost equal to a half. So we have a y value. That is what's plotted right here. Okay, and of course we have some other y values up here, which represented those other y values as we got closer to 1. Okay, you know what's going to happen as we go to the next quadrant. The y values are going to get negative. So now we have negative y values that are being graphed. And of course, we're back to a y value of 0. It's kind of strange, but we're like undoing the sine wave. Okay, so I know it's kind of mathy. It's mathy, but the graphs that are in your book come from the unit circle, and simply the values as you go around, the values that you get. Now, the tangent that's kind of AWOL because the tangent is y over x. And so now we're dividing numbers and you end up with a 0 in the denominator. So you get asymptotes. Look where the asymptotes are for tangent. They're at pi over 2, negative pi over 2. Now, sometimes at this point, kids will ask, do I need to know this? Meaning, like, should I know this without a calculator? Sine, cosine, and tangent. Yes, you should know sine, cosine, and tangent as a math student. You should be able to draw a cosine graph. It starts up at the top. You should be able to draw a sine graph. It starts at the origin. Tangent, like I said, it gets a little more AWOL, but it has asymptotes. And I'm going to actually go over a tangent problem. And those asymptotes are at those places that, you know, when it comes to studying for a test that you'll want to know. Okay, notice the period of tangent is pi. Okay, that means it only takes half as much to see a cycle. The period is only pi. And by the way, that's the distance between the asymptotes. That's why the light brown and dark brown are between the asymptotes. Okay, now the other graphs at the bottom, lovely. Those are the reciprocals. Just first off, you don't need to know those without a calculator, but you should have knowledge of them. You know, if you graph them on a calculator, that you're not surprised what the graphs look like. They have positive and negative branches. They also have asymptotes. Careful, the period of secant and cosecant are still 2 pi. It takes 2 sets of asymptotes, 2, to see a full period. By the way, the period matches with sine and cosine, which is also 2 pi. And then you have cotangent. Okay, fun stuff, good stuff. Let's talk about what we can do with it. Okay, what I'm going to do now is show you guys a transformation formula for the trig functions. This is a transformation formula. I'm kind of moving away from page 41. That doesn't mean necessarily close your book, but we're going to kind of add a little bit. Sort of some good news. You're not going to remember this from last year. That's good news because you don't have to feel like you're the only one. The reason being is because it's in radians and it has a slightly different format. You're still going to feel like, though, I hope, that there's some things that sound like last year, but you won't be the only student if you're like, whoa, okay. All right. A, that would be like a coefficient on a trig function, maybe sine, cosine, or tangent. It's kind of weird. I'm just writing the word trig function, but there could have been like a sine or a cosine or a tangent there. So it's A times a trig function. And then, well, I shouldn't say and then, it's always going to be a trig function of theta. Okay, so it'd be like the sine of theta, cosine of theta. And then there's going to be a fraction, which you guys will come to learn, will be like one of the main things you have to think about, because this fraction, first of all, could have, whoops, that was supposed to be the word or, my bad. It's 2 pi or pi. Sorry about that, 2 pi or pi. So it could have selections of numerators. You'll have to select the numerator, and then it's got this thing in the bottom called b. And then maybe we get into some more comfy zone here where we see an x plus or minus c plus or minus d. I goofed a little bit, my bad. There's not going to be a theta here because, well, it's actually right here. It's this x. So that actually wouldn't have made a whole lot of sense. We would have realized it in a second. Just get it out of there. Okay, now listen, first of all, if you're like, am I going to need to memorize this? Let's not even worry about that right now. Let's just learn how to work with it. Let's just learn how to work with it, and then we'll figure out and maybe realize that, okay, when I give it to you, it's not going to look so complex because basically we're going to have numbers and stuff in here. But still, let's talk about the parts of this fraction. Whenever you have, or the parts of this formula, whenever you have a coefficient, okay, the coefficient is always going to be the amplitude. It's always going to be the amplitude of your trig function. Maybe sound familiar. Remember, amplitude talks about the maximum and the minimum that the sine and cosine graph can travel. So the amplitude is always has to do with that height. Now, b, in the way that this is being presented to you, b is the period of your function. We talked a little bit about the period as being that distance that you have to travel to go through a full cycle. Okay, so b will be the period. Now, these numerators up here, it's kind of like there's two of them, but these numerators represent the original period. The original period. And quite simply, that's referring to either the original period of sine or cosine or tangent. And so I think that this will be, you'll realize, okay, depends on if we're doing sine, cosine, or tangent, that you'll choose 2 pi or pi. Okay, because 2 pi goes with sine and cosine, and pi goes with tangent. Now we get over here, and we start to get into maybe some more familiar territory, because anytime you add and subtract things in an equation, you're shifting. This is a horizontal shift. Horizontal shifts are always when you add or subtract on the inside with x. For these fancy trig graphs, we like to think of that as the horizontal shift of the y-intercept. In other words, it's the y-intercept that's kind of your shifting point. Now, when we have a number on the outside, that's also a shift, but that's always a vertical shift. That's a vertical shift. When we talk about these fancy trig graphs, it's a vertical shift of the midline. It's a vertical shift of the midline. And the midline is that horizontal line that travels through the middle of your sine wave and your cosine wave. Okay? It starts out as the x-axis, but maybe it shifts. Okay, now I'm not standing up here and saying, hey, you should know this, but let's work with it. Let's work with it. It's kind of like taking something that's challenging and trying to kind of break it down. We're going to break it down a little bit. One of the things that we're going to try to do is we're going to try to understand what would be true about this equation. In other words, what would be like the features of 2 sine of 3x minus 4? What's its amplitude? What's its period? How about maybe other pieces, like maybe we'll draw a graph, which we will. So we're going to try to analyze this thing. See, I told you, when you write it out, it does look a little bit easier than this. Okay, but we want to try to connect it. Now, probably the easiest connection is the amplitude. That is the same as last year. The amplitude is going to be the coefficient. If that was the only thing that we had on this problem, you would have a sine wave that's stretched 2 units high and 2 units low. Okay, so instead of stretching 1 unit high and 1 unit low, it now stretches 2. Think about it. That's what happens when you multiply to the front of an equation. It stretches the y values. Now, the period. Okay, just kind of to be honest with you here, it's a little hard to find. You have to be ready to think. Honestly, on a test, I'd rather you tell me that you know the period is not equal to 3 and sort of like be honest and say, Miss Neal, I know it's not equal to 3 because you said it's something I have to think about. So what I'm kind of bringing up here is don't say 3. I'd rather you actually tell me that you know it's not 3. But it has to do with the number 3. Okay? It has to do with the number 3. So what we have to do is we have to kind of find the period. Now, over here, the period is the denominator. And I would hope that every student here at least says, hey, where's the fraction? Where's the denominator? Like, I don't see anything. Like, where's the numerator? Okay, that's the part where you have to take the number 3 and you have to fit it into this thing. And I don't have a name for this thing, but it's the fraction. Okay, what do I mean we have to fit it in? What you have to do is you have to understand that 3, now I should mention here, 3 is the coefficient on x. That's pretty obvious. But this fraction, which has the period, it's also the coefficient on x. Okay, so whatever's the coefficient on x is always this fraction. So 3 just needs to equal this fraction. Now, in this fraction, we have the infamous b. It's what we're trying to find. Do you realize that the numerator just needs to kind of be determined? So we just have to choose it. Okay, and you just choose the numerator to match the trig function, because the numerator is always going to be the original period. Since this is a sine wave, the original period is 2 pi. It's actually not that bad. I shouldn't set it up like this is the worst thing ever. All you got to do is solve that for b. But you have to realize that you're solving it for b, and that will be the period. Okay? Please do good algebra. Okay, good algebra might be to cross multiply. It might be just to understand that you're going to switch the positions of b and 3. You're going to solve for b. b equals 2 pi over 3. That's the period, 2 pi over 3. Okay, now remember, a sine wave has a period of 2 pi. Okay, it takes 2 pi to go from beginning to end. Now the period has shrunk. Actually, it's shrunk significantly because 2 pi over 3 is much less than 2 pi. Okay, so we have a shorter period. Okay, kind of doing, what do you call those instruments where you go like this? Accordion. We're kind of doing accordion to it. Thank you. By the way, I enjoyed listening to everybody's Evernotes. I kind of just remember that because I enjoyed listening to you about bowling and the other things. I don't remember everything, but it was fun listening to it, especially how you guys so nicely, at least you felt like you had to do it nicely, but it would have been all right if you said, and I want my bonus point. Give me my bonus point. But people are like nice about it. I would like my bonus point, please. All right, I enjoyed the Evernotes. What else are we doing here? We're trying to analyze this thing. -4, it's the only thing left. Now, listen, as students of math that you are, I mean, you're in here, so you're a student of math. You can't, don't do this, you can't say, oh, that would be the same thing, or that's what it is, right? You just made a new problem. You just made a new problem because ultimately you have said that it's not even a 4 that's there, it's a 12. And now you've said that that number is on the inside when it actually was on the outside. So you can't just put parentheses in if they're not there. Okay, if we were going to put parentheses, it would only be around x, which you usually don't see. But I'm trying to show you, I'm trying to tell you that this is an outside shift. This is a vertical shift. And so we would say so. I guess we would say over here something to the effect that we have a shift down 4 units. We have a shift down 4 units. All right, now, hey, it's not that bad. And I can't wait to get to calculus because I really think you're going to enjoy it. But this ain't too bad. We can come up with these numbers. Now it gets a little more interesting, trying to draw a sketch. Now, without just typing this in your calculator, let's have a talk. First of all, a sine wave that has an amplitude of 2. And by the way, I'm going to be making this sketch in phases. And so it could be that what I draw might not end up being the final answer, but I'm going to put this in some phases. First of all, an amplitude of 2 kind of helps me to picture a graph that is going to go as high and low as 2. And speaking of picturing a graph, this is what I said nicely, that you should know that the sine wave starts at the origin and then goes on its merry way. So now you say you can just draw that. Well, yeah, I can draw it. That's the sine wave, because it kind of allows me to then start to put the period into it. The period is 2 pi over 3. So that would allow me to know that the graph is going to end at 2 pi over 3. By the way, it started at 0, but it's kind of implied. That's an x-intercept. Honestly, I might ask you for an x-intercept. Please understand that the x-intercept was connected to the period. There's another x-intercept. We're starting to travel further into the problem, but isn't that x-intercept also connected with the period? That x-intercept would be half of the period. Okay, now we're doing a little bit of, okay, I got to do half of 2 pi over 3. Okay, half of 2/3. Oh, 1/3. 1/3. So pi over 3. I'm not going to give you like a really weird fraction. So we're finding half. Now this gets a little bit more into the weeds. But if I asked you for like a maximum, that also connects to the period, to half the period, to another half. So now we're trying to do half of pi over 3. That'd be pi over 6. Again, I'm being honest, that's getting a little more into some details maybe that we would do in a trig class, but we could find it. Is the bell going to ring on me? Okay, the only thing we didn't do is shift this puppy down 4 units. You just have to do it when you come back. But all we're going to do is take this thing, pick it up, and move it down 4 units. And that ends up being like our final graph. Okay, take a break.